Alright, let's talk about our laws of exponents. So there are a couple of laws of exponents. We're gonna do one video per law, or one law per video. So let's have a look at the first one. So the first law of exponents looks like what we have over here. This writing that's gonna be on the side red and blue is a sort of easy way to remember your conditions and your result. If there are two bases, so let's look at our first. It's here's a base and a base that are the same. All right, so they're the same base and are being multiplied. So there's a times between them. So a base and a base both are the same, and there's a times between them. Then keep the base. Okay, we're gonna keep the base, and then we're gonna add the exponent. So this exponent plus that exponent, m plus n. Now, why are there two other lines here? It's because multiplication in maths can be written differently. So a to the power m times a to the power n is the same as putting a dot instead of a times sign or bracketing one of those two terms. But the idea is that they're still being multiplied and still follow your first law of exponents. Now, if you somewhat understand what I just said, try and pause the video, attempt all 12 of these questions, or just the first three, and then play the video, check the answers out, compare, and then do a few more, and just so you get a sort of hang of it, alright? Even if you want to just watch me do the first one and try, but definitely take some time to do some on your own. So 3 to the power 2 times 3 to the power 5 is going to be 3 to the power 2 plus 5, which is 3 to the power 7. Next one, 2 to the power 4 times 2 to the power 3 is 2 to the power 4 plus 3, which is 2 to the power 7. 5 to the power 2 times 5 to the power 3 is 5 to the power 2 plus 3, which is equal to 5 to the power 5. So obviously you're checking for these conditions, like we've got identical bases to being multiplied, so we add exponents. You've just got to keep checking for that. Number 4, the bases are the same, it's 3, so we keep that same 3 as a base. X plus 2x, and x plus 2x is going to be 3x. X squared times x cubed, well, we're going to say 2 plus 3. We're going to keep the base of x, and it's going to be x to the power 5. Next one, x, if there's no exponent, it's an invisible 1. So x to the power 1 plus 2, so it's x to the power 3. For the next one, we're going to look at them separately. So x has an invisible 1 here, so we'll do x first. X to the power 1 plus 3 times y to the power 2 plus 4. So it's x to the power 4, y to the power 6. Let's check out this one. So in this case, there's no x to match it, so x is going to remain the same. This y has an invisible 1, so it's y to the power 1 plus 4. X squared comes down, and y to the power 5. For this one, we have the same base being multiplied, but there's 3 of them now. But the concept doesn't change. If you were to do it, you would say, let's do this, get your answer, and then you could do it to this as well. But we can do it in one step. 3 to the power 2 plus 3 plus 4. So that's going to be 3 to the power 9. For the next one, again, this is also time. So it's the same as before. But let's make a note. There's an invisible 1 and an invisible 1. So for the x, we have 2 plus that invisible 1. For the y, we have 1 plus 2 plus 3. So it's x to the power 3, y to the power 6. For this one, we're multiplying, so it becomes, there's an invisible 1, x to the power 2 plus 1, y to the power 3 plus 2, and just z to the power 4. So it's x cubed, y to the power 5, and z to the power 4. For this one, we are multiplying, so you multiply coefficients if there's not identical base. So you would say 4 times negative 3, alright? So 4 times negative 3. And then you get x to the power 2 plus 1 and y squared. So your answer is negative 12x cubed y squared.